But sir, what is the difference between Stata, panel data analysis, and then eViews?
No, Stata is one kind of software, and panel data is the structure of the data set.
Right, sir.
Right. And
And
eViews is another type of software that we generally use for the analysis of particularly time series data.
okay,
But
sir.
with the help of eViews, how the panel data problem can be solved,
Hmm.
that I will discuss today. So
Okay, sir.
that you will also gain some sort of knowledge about another software, that is eViews.
Okay, sir. Understood.
So yeah, so in the latter case, when we will conduct different types of time series analysis, then obviously the eViews software will be used. So this eViews software is very, very useful and user friendly software. So first I will show you how to open the eViews. I have one versions of eViews 10. So just I'm sharing my slide. This is the eViews icon, basically used for time series analysis as well as panel data analysis. So just I'm clicking on this software, double click, then the software will be opened. Now we have already a data set, so that's why we are just closing it. First, we have to import our data set to this eViews software. And I have already told you, in case of Stata software, analysis option is statistics. But in eViews software, for analysis purpose, the most common icon is quick. Quick is used for analysis purpose. So in case of Stata software, you have observed that statistics is used, and in case of SPSS software, quick and statistics are not used. There only the simple option is there, that is analyze. So it varies from software to software. Whatever the icon is used in different softwares. So in our eViews software, this is the option, that is quick. It is used for analysis purpose. First, we have to import our data set. So I'm just clicking on file, click here. Then this is your import option. So from file, you are coming to import option, then import from file. Just I'm clicking here. Yes. Now I'm going to desktop, Stata training, day 5. I'm just taking my Excel file. Just click here. Then you just click on open. Yes. It will look like this. Then you just click on next 3 times. One time, next. Then again you click on next. Again you click on next. So 3 times you click on next. Then after that, you click on this bottom finish. Yes. Now link imported series and alpha objects to external source. You click on yes, because you are importing the Excel file to this specific software? So your option is yes. Now, what will happen? All the folders have been created. All the folders have been created. And whatever the variables we have taken into consideration, just I'm showing you the variables so that it will be easy to understand. Yes. So we are taking state. State is used for panel ID or the cross-sectional unit. We have taken 17 states and we have considered 3 years, first year, second year, and third year. And we have considered 3 macro variables. Out of these 3 macro variables, I have already told you in yesterday class, this is my poverty ratio, which is dependent variable, and RNFW, rural non-farm workers who are working in non-farm sector. This is your independent variable, and literacy rate is your independent variable. So as we have 17 number of states, and for each state, we are considering 3 time periods, first year, second year, and third year. Therefore, in total, we have 17 into 3, that is 51 observations. That is 51 observations we have. So just I'm closing my data set. So our variable abbreviation is POV, RNFW, LIT, year, and state. Just I'm closing it. Now come to the software. All the folder have been created. This is your folder, poverty, then RNFW, then LIT, literacy rate, then state, then year, and the software automatically have created other folders. One is C, that is for constant purpose. When we are establishing any regression equation, so obviously in that regression equation, one constant term is there. As well as when we are establishing regression equation, I have already mentioned residuals part is there, which is non-explained part. That purpose, another folder will be automatically created to this software. So we have considered 5 variables, but here we are observing 7 folders. 2 extra folders will be created. One is for constant purpose, another is to capture the residuals from our regression equation. And other 5s are already defined by us. Literacy rate, poverty ratio, RNFW, state, and year. And if you want to see the data file from here, then just you select poverty, then literacy, RNFW, state, year. Just I am pressing the control button. Now, just you show, okay, just a second. Yes. Open as group. So at a time, you can see the data set. At a time, you can see the data state. Literacy rate, poverty, RNFW.
Sir, in eViews, The
Yes.
data as per variable, for each variable, it is contained in a separate folder.
Yes.
So your Excel sheet, it was containing one sheet with all the variables, and
Exactly.
eViews is converting each variable data into a separate folder.
Separate folder. Right. Right.
Okay, okay,
So just you select it
okay.
by pressing the control,
And then we have to
and
see it as a group.
yes, click on your mouse right button,
Uh,
then open as a group.
okay,
Yes.
okay,
And
sir.
if you only show the one variable,
Hmm. Then factor wise.
yes, just literacy. Just double click on this folder.
Okay, sir. Understood, sir.
Just double click. Yes. In this way, it will be shown. Now, first I will show how to establish pooled regression equation in our eView software. So I have already told analysis purpose, we must use this button, that is quick. So I just click on quick button. Then your intention is to estimate an equation. Therefore, you just click here, estimate equation, and you just click here. So equation estimation specification box, it will come. This is called specification box. And what is its uniqueness? In this specification box, you have to specify what variable you have taken as dependent variable and which variables you have taken as independent variables. But you remember about the Stata software, Stata will ask you which one is your dependent and which are independent variables. Separate box will come to you. But here only one box will come to you. There is no separations of dependent and independent. Right. So it is only one specification box where you have to specify your dependent parameter as well as your independent parameters. So the rule is when you are writing the name of the variables into the specification box, the rule is first you have to mention your dependent variable. First you have to mention your dependent variable. So here the dependent variable is poverty ratio. So just I'm typing here P. When you are typing P, all the variables will come to you. Just you click on poverty. Clear. No need to write anything. Just you write the first letter. So POV, then you are using C. C stands for constant. If you do not give C, then your equation constant part will not be shown. Suppose I am not giving C. So let's see what happens. And after that, we'll put C. Then we can see the difference, the use of constant. So poverty, then space, then you have to mention all the independent variables that you have considered in your study. So here we have considered two independent variables. One is RNFW, another one is literacy rate. Just I'm writing L. Automatically it has come. Then double click. Then space. Then R. Then RNFW. Just double click. RNFW. So you have already specified. The software can understand the first variable is the dependent parameter and all other variables that you have inserted, all these are independent parameters. Now you just click on OK. The equation will come to you. Just I'm clicking on OK button. Yes, I'm just extending it. So what you are observing, the EViews software, one specific date and time will be mentioned when you are establishing the equation. When you are executing any command, the date as well as time will be mentioned. And the sample is 51. So I have already told you total number of observation is 51. And how many periods we have considered? Periods included 3: first year, second year, and third year. And cross section includes, that means total number of panel ID variables. In our case, the panel ID variable is states. So I have already told you we have considered 17 number of states, and total observation is 17 into 3, that is 51. So this is the summary of your observation. Now just come to the result window. In this result window, our intention is to see the coefficient of our independent parameters or explanatory parameters. So in case of the literacy rate, the coefficient value is 0.46. And what is the value of the T statistics? 2.31. That means
More
good.
than 2.
Yes, yes. So obviously when it will be more than 2, the probability value by default it will be significant. So here it is 2.31, and what we are observing, the probability value is less than 0.05. That means your probability value is significant. Therefore you can say that in your study, literacy rate is a significant variable. You can say in this way on the basis of the T statistics and corresponding probability. So in this case, literacy rate is a significant parameter in your study that can explain the fluctuations of poverty rate. That can explain the fluctuations of poverty rate. How can you interpret this? You can say that if you change 1 unit of literacy rate, if you change 1 unit of literacy rate, then there will be change of 0.46 units of poverty. Again, I'm saying, how can you interpret? If you change 1 unit of literacy rate, 1 unit of literacy rate, then 0.46 units impact will be there on the poverty ratio. That you can say. But before saying this, you have to be sure that this independent parameter is significant, that by inspecting the value of T statistics and the corresponding probability. But when we are coming to the second independent variable, what we are observing, the yes, the coefficient's value is positive, but the T statistics is less than 2, as well as the probability value is not significant. It is greater than 0.05. So out of these two independent variables, if you watch that, if you observe that only one independent variable is right, therefore you have to accept this model, because I have already told you the characteristics of a good regressions model, at least 50% of the variable must be significant. As you are considering two independent variables, so at least one variable has become significant. So you can accept this model, but you have to observe the other characteristics. So in this way, we can interpret this. Now just I am inserting C or the constant. How I can insert it? You can go to quick, or you can go to this option, that is estimate. There are two options. One is, if you click on estimate, directly you will go to the specification box. Just I'm showing you. Just you click on estimate. Directly you are coming to the.
Excuse me.
Yes, yes.
Sir, in this case, without C, the R squared value is coming in negative.
Yes, yes. But this is not because of C, right? This is not because of the constant term. If you insert the constant term, although it may happen. So let's see what happens, right?
But sir, R square value should always be positive, sir.
No.
But may I intervene?
Yes, yes, yes.
If we estimate a model without intercept term, then R square may come to be negative.
Exactly,
Okay,
exactly.
Okay,
It is theory. It can
Yes.
be proved.
Yes, yes. So
Okay,
we
sir.
are now just inserting a
Because
constant.
generally it is positive, no, sir. That's why
Yes,
my
yes.
question came.
Generally, it is positive, but when we estimate a model without intercept term, then R square may be negative.
Okay, sir.
May be negative, right? It is
Thank
not
you, Vishnu,
necessary.
sir. Thank you.
So just we are inserting C, then what happens? This is now become positive, 0.19, right? This is now become positive. Now,
Yes,
if you just click on quick, we are not clicking on estimate now. We are just click on quick. Then again, you have to go through this estimate equation. Then this portion is blank. So again, you have to write the command. That's why my suggestion is, when you have already established one equation, then you need another equation, then you just use this option, that is estimate, right? So it is less time consuming process. Or otherwise, if you forget to click it, then you go to quick, then estimate equation. The same results you will get. Poverty, C, RNFW, then literacy rate, then OK. So delete the untitled equation. That means the first equation's results will be removed. Now the software is giving you the new result. Yes. So this is your.
In this program, there is no need for making a log file like in Stata.
No, here we are not using the log file.
Okay, so there is no need for generating any log file.
Yes, yes, yes. We are not using the log file. So now this is the pooled regression equation. So now we will show how to run the fixed effect model, and after that we will compare whether the fixed effect model or the ordinary least square model, which one is comparatively better. That decisions we have to take. So
here,
yes,
this model is not a fixed effect model, sir.
No. This is pooled regression.
Okay.
This is pooled regression.
But sir, is we have to do the analysis of this pooled regression also?
Yes, we are just showing pooled regression, but we have to show you the fixed effect model as well as the random effect model, right?
Okay, sir.
First I'm showing the pooled regression.
Okay.
Yes.
But sir, looking to this data, it seems to be a model which is not good enough.
Yes. So let's see what happens in case of the fixed effect model and random effect model, right?
Right, sir.
So just I am going to estimate, not going to quick. Estimate. So I have already specified the variables, but I have not specified whether I am wanting fixed effect model or random effect model. So when we are not mentioning anything, then the software can understand this is a case of pooled regression, right? So initially what we do, we have written this command, and after that we click on OK. And we have got the result of the pooled regression. Now you have to choose the panel options. Clear? So just to click on the panel options, then go to cross section, effect specification. You are going to cross section. You just click here. Then you choose the option fixed. Yes. Now whatever the result you will get, that will represent the equation, and your assumption is you are doing fixed effect model. So for fixed effect model, you have to choose the option under cross section box. You are choosing the option. There are three options. One is none. None means you are getting pulled, then fixed, then random. So now I am clicking on fixed. Now just you click on OK. Yes. This is the result of your fixed effect model.
Very
So
good model,
when,
sir.
yes, when we are clicking on fixed effect model, and whatever the results we have got, just we are observing on RNFW, because in the pooled regressions model, the RNFW, this parameter was insignificant.
Yes,
But
sir.
in this case, RNFW has become significant because the probability value is less than 0.05. And I have already told you, when you are getting the value of negative value of the t statistics, you just assume that you are using the mod. So when you are using the mod sign, this negative value is becoming positive. Then you compare with the thumb rule of 2, right? So
Right.
otherwise there is no problem. So in this case, the probability value is significant. In case of the constant, the probability value is significant. In case of the literacy rate, the probability value is also significant. And what is the interpretations of C? Because whatever the value we are getting, this value is not being affected by these independent variables. This is the free value. This is the free value, right? This value is not being affected by the influence of these two independent variables. That's why we are considering this is the constant term. This is constant term. This is not variable, right? So this is the constant term, and these are other two coefficients of our independent variables. And we are now just explaining this. Just explaining this. Here the R square is 0.88. Very good value we have got, and the F statistics is 13.80. And whether this model is fitted model or not, that's why I have already told you you have to inspect the value of the probability of F statistics. The value of probability of F statistics, bracket in bracket it is also mentioned, F statistics is less than 0.01. That means your model is fit. Another thing is that you can also interpret, that is the result of Darwin-Watson statistics. And these statistics is mainly used to check the autocorrelation. This is the checking of autocorrelation, and thumb rule is that it must be closer to 2. It must be closer to 2. But this value is quite higher. It is 2.53. So let's see what happens in the next case. But the model is fit, and the regression coefficients are also significant. The constant value, this is also the t value is also significant. So apparently this model is good. Apparently the model is good. Now the question is, we have to compare this model with the normal OLS. With the normal OLS, we have to compare this fixed effect model. Now, for comparing the fixed effect model, what happened in case of the EViews, when we are comparing the fixed effect model with OLS, then the result of the OLS will be shown to the software. So just I'm clicking on view option, then you select this option, fixed oblique random effect testing. Then this is your redundant fixed effects likelihood ratio. This test is conducted for the comparison between ordinary least square or pooled regression versus fixed effect model. So this is your fixed effect model. So just you click here. Yes. Now what you are observing, the result of normal model, that means the result of pooled regression model has been shown here. You just try to remember,
Yes, sir.
this is the result of pooled regression, RNFW,
Correct, sir.
insignificant, right? So this is the result of your pooled regression equation, and you have already got the result of fixed effect model. Now to determine which model is comparatively better, that's why you have to check the F value, F statistics, which is known as the restricted F test that we also did in case of the panel data. And these F statistics, this is the value of the probability is significant. And you can also check it cross section chi-square, but the main preference should be given on the F statistics. In this case, the main preference will be given on the F statistics. And if the probability value is significant of F statistics, then our conclusion is we can say that our fixed effect model is comparatively better than the normal OLS or pooled regressions model. And when you have decided fixed effect model is better, then obviously you have to run the fixed effect model once again. Then you have to check various types of diagnostic checking. That is, there are 3 types of diagnostic checking we can do. I have already told, that is, one is autocorrelation test, another is a heteroscedasticity test, another is normality test of the residuals. That's why these 3 types of test in our EViews, in our time series analysis, it is called as diagnostic checking, right? This is called as diagnostic checking. Under diagnostic checking, 3 things have to be checked. One is the normality, the second one is serial correlation test, that is autocorrelation, another one is the heteroscedasticity. So just I am showing you because this is the new software, so you have to learn how to check the diagnostic checking. So for this purpose,
Sir,
I
in
have
this
to
case-
run.
Sir,
Yes.
can you please explain this upper table, sir, in this case?
In this case, you have to show the result of restricted F. That means F statistics. F statistics.
Yes,
And
sir.
here the F statistics value is 12.08. But
Yes, sir.
this value, whether this value is significant or not, that can be checked by here. This is your probability value. This is your probability value. And if this probability value is significant, then you are sure your fixed effect model is comparatively better rather than the pooled regressions model, right?
Okay, sir. That is the only thing, sir.
Yes. And that is similar to the panel data, restricted F test.
Okay, sir.
Yes. Now, when you have decided that your fixed effect model is better, so you have to run this model again, right? For diagnostic checking purpose. So just click on estimate, and already we have given this option, fixed option. So okay, now the fixed effect model result has come. Now you are making some diagnostic checking. How? In the EView software, for diagnostic checking purpose, for diagnostic checking of the residuals of our regressions model, we must use this option, that is view. From the result window, you just notice that one option is there, that is view. And if you click on this option, then you are coming to this option coefficient residual diagnostic, because your intention is to do some diagnostic checking of the residuals. So you just come to this option, residual diagnostics. So first is your histogram normality test, whether your residuals are approximately normally distributed or not. So you just click here.
Yes, sir. It is almost normally distributed.
Yes, it is almost normality, but when you are using the eView software for checking the normality, we use one particular test that is called Jarque-Bera test, Jarque-Bera statistics. And here the Jarque-Bera result is 0.14 and the probability value is greater than 0.05. That means it implies that our residuals are approximately normally distributed. The question is why? Because here our assumption is our data residuals are approximately normally distributed. This is our null hypothesis. Our residuals are normally approximately normally distributed. So as the probability value is greater than 0.05, therefore we cannot reject our null hypothesis. We will accept our null hypothesis, and accordingly we can say that our residuals are approximately normally distributed, right? And all other descriptive statistics results have been also given here: mean value, median value, maximum, minimum, standard deviation, skewness, and kurtosis. But for checking of the normality, you give concentration on Jarque-Bera statistics and its corresponding probability. If the probability is less than 0.05, then you can say that your residuals are not normally distributed. So this is one diagnostic checking of normality of the residuals, and this is the very important checking. And second is, you can also check Passer-Run CD test, that is for serial correlation. Passer-Run CD test.
Sir,
Yes.
this Jarque-Bera value and probability, these are two different values. We have to see probability only or Jarque-Bera value?
No, when you are reporting, you will mention that Jarque-Bera, this is the value of the statistics.
Right, sir.
And whether this value is significant or not, that can be judged with the help of the probability. Right?
Okay, sir. Okay, sir.
Yes.
So I thought that there must be some parameter like Jarque-Bera should be more than 2.
Okay. No.
Is there
So
any?
when you will report, then you will just write that from the residuals you have checked the Jarque-Bera statistics, and the value of the Jarque-Bera statistics is 0.14, and which is significant, which is not significant. Therefore, you are saying that your residuals are normally distributed, as your null hypothesis is residuals are approximately normally distributed, right?
Okay, sir. Okay, sir.
Yes. So next is Passer-Run CD test, that is done for serial correlation or autocorrelation. So just you go to view, you are coming to this option, residual diagnostics. Then you click on cross-section dependence test. Just to click here. Yes. Now, I have mentioned the name of the test. In case of the panel data, you have to focus on this test, Passer-Run CD test. And if the Passer-Run CD test, if the probability value, this is the Passer-Run CD statistics, but this is not more important, but the important thing is the probability value. So the probability value is greater than 0.05. That means the probability value is insignificant. Therefore, we can say that there is no serial correlation. So already the software has mentioned the hypothesis. No cross-section dependence in bracket correlation in residuals. So there is no such type of problem in this model. So that can be judged with the value of the probability. If the value of the probability is not significant, then it is better. If the value of the probability is significant, that means there is a problem. There is a problem of serial correlation in the residuals, right? So this value is very important. This is the last row, PASARN, PASARN CD test. So in this way, you can check. And another test that I cannot show here because our software will not permit it, because this is the pirated software. So although I am showing you residual diagnostics.
Sir, so in this case, in this PASARN test, the value of probability is more than 0.05. So it is not significant. So we can say that there is no cross correlation.
Yes, there is no cross correlation. Right. Or serial correlation, or the term is serial correlation.
Sir, if time permits, please explain the concept of cross correlation and auto correlation.
Yes.
Because these are a little bit confusing terms.
Very good question. I'm just explaining it. Autocorrelation means when you are observing only one particular variable, values of one particular variable. Suppose I am taking the values of poverty ratio, right? So when we are giving concentration only the values of a particular variable, and if the values of a particular variable are interrelated with one another. Suppose you are taking one variable, that is poverty, and you have considered 20 values, but these 20 values are intercorrelated. Then that is called the problem of autocorrelation.
But how can those values will be interrelated? Because those are independent values, sir.
No. That's why you have to check whether these values are independent or dependent.
Okay.
Right? Because you are taking the stock price. Because you are taking the suppose stock price. So it might be like that one stock price is correlated with the previous stock price.
Okay.
Clear?
But sir,
so that's why.
How is it possible, sir? Correlation, because on
no. Sometimes one value may be dependent on another value.
Okay.
Sometimes one value may be dependent on another value.
Okay, sir.
So you have to be sure, whatever the values you are taking, whether all these values are independent or not. Okay. That's why you are checking.
Okay, sir. So,
so these are called the diagnostic checking.
Okay, sir. If those 20 values are not related to each other, they are not correlated, then we can say that there is no autocorrelation.
Exactly.
No, Sadhvirji,
there is no autocorrelation.
They can be correlated, but not autocorrelated.
Not autocorrelated.
Then, sir, Roy sir, that's what I was asking, sir. The autocorrelation.
See one thing, if there is increase in inflation, there could be also increase in interest rate. So if you take both the variables, if they are highly autocorrelated, so or say if you take interest rate based on previous data, okay, right? They can be autocorrelated, right? And if you take interest rate and inflation rate, there can be multicollinearity. So you have to understand.
No, Roy sir, you are talking about correlation between two variables, right?
Right. And right, and this is the.
Whereas sir was giving the example of 20 observations in a particular variable, and the relationship between individual.
That is an autocorrelation. Supposing you take the figures of interest rate previous day before yesterday, then you will find autocorrelation over there.
Right.
Am I correct, Dr. Biswas?
Yes, absolutely correct. That I am trying to say. If the interrelation among the values of a particular variable exist, that is the situation of autocorrelation.
Okay, sir. Which we should avoid.
Right. Yes. So
Okay.
that is the problem. If autocorrelation arises, that is the problem. So if autocorrelation is there, if multicollinearity is there, then you cannot say that your regression model is perfect.
Okay, understood, sir. Sir, what is cross correlation, sir?
Yeah.
Then what is the
Yes,
concept
yes,
of
I
cross
am just,
correlation?
yes, yes, yes. I'm just explaining. Now the question is, suppose in case of two variables, you are taking two variables, right? So obviously one variable is dependent and another variable is independent. Then if there is a relation, that is not a problem. But,
Okay, sir. Okay, sir.
when you are considering two independent variables, that means when you are claiming that your variables are independent, but we are observing that between these two independent variables, there is some sort of relation.
Okay.
Clear? That is also not desirable.
Okay, sir. Okay. Then there is no point of having both the independent variables in our analysis.
Exactly, exactly. So in case of the regression, this is a very vital thing. One is the autocorrelation, another is the serial correlations, right?
So, sir, multicollinearity problem, what we study, it is, I think, same, related.
Yes, yes. One is called linearity, collinearity. Another is called multicollinearity. When we are talking about collinearity, that means only there is a relation between two independent variables. But when you are saying the multicollinearity, that means more relationships are there among the independent variables.
Okay.
Suppose you are taking 5 independent variables into your study, right? 1, 2, 3, 4, 5. Suppose there are 5 independent variables. Now what we are observing, there is a relationship between 1 and 4, 3 and 5, 2 and 5. Clear? So it is a case of multicollinearity.
Okay,
so this problem must be avoided.
Right, sir. Now understood.
So another is Another is heteroscedasticity states, but I cannot show it because our software will not permit it. So just I am clicking here. So the option is coming cross-section effects with pure JLS weights not allowed. So I cannot check this. So I am just checking the autocorrelation and serial correlation test. So these are called the diagnostic checking. Now we are coming to this point, that is the random effect model. Just we are clicking on estimate. Yes. Now again you have to specify which effects you are wanting. Go to panel options. Then earlier we have given the fixed option. Now we are changing it. So you have to change, you remember that, from cross section. Random. Now you just click on OK to get the result of random effect model. Yes.
It is slightly poorer than fixed effect.
Yes. But other things we have to observe. Although the R-square value is 4, but one thing you observe, in case of the Darwin-Watson value, it is closer to 2. But in case of the fixed effect model, the autocorrelation problem was there because the value was 2.53. Can you remember this? 2.53. Yes.
Yes, sir. Yes, sir.
This is the result of the fixed effect model.
So here we can say that there is autocorrelation problem.
Yes, obviously. We suspect there is a problem of autocorrelation.
Okay, sir.
So in this case, that's why we have to compare which model is better, fixed effect model or random effect model. Because in case of the fixed effect model, on the basis of the F statistics and the probability value, what we say, the model is fitted, right? But in case of random effect model, yes, in case of random effect model, what we are observing, all the probability values are significant. All the probability values are significant, right?
But sir,
All the probability values are significant. But
RNF
But,
value is,
but, yes, R square value is quite low. R square value is just medium. 51% is explaining. But Darwin-Watson result is also good. Now let's see what the software suggests. Clear? Yes.
but sir, in RNF value, it is more than 0.05. It is closer to 0.05, but it is exceeding.
Closer to, yes, it is closer to 0.05.
So we can take it
Closer to
significant.
You can also say that at 6% level of significance, the value is significant.
Yes, sir. Yes, sir.
Yesterday I told you, no?
Yes,
Up
sir.
to at most we can go for 10%.
Correct,
At
sir.
most.
Yes, sir. Yes.
Right. Yes. So
in this case,
now
F
this is the
static
result.
sir, in this case, probability of F static is significant. So we can say that
Yes,
this model is
also-
also good.
The model is, this model is also fitted model
Yes, sir.
because the F statistics is also significant.
Yes,
The
sir.
model is fitted model. So fixed effect model is also fitted. Random effect model is also fitted. Now we have to compare which is comparatively better through specific test that I already told you in case of the Stata. That test is known as Hoffman test. Can you remember?
Yes, sir.
Hoffman test.
Sir, in this case,
Yes.
what about unweighted statistics? Do we need to mind all these in the last portion of this table? In this results table,
This
unweighted.
portion.
Yes, sir. Do we need to look into this?
No. You do not need to report this, all this.
Okay, sir.
Right?
Okay, sir.
All these things. Just
Only
you report the
weighted.
weighted statistics. Yes. Yes. So for comparison purpose, we are just going to view option. Then we are coming to fixed oblique random effects testing.
Yes, sir. Lagrangian.
Yes, no, Hoffman test, because you are comparing fixed effect model versus random effect model.
Okay.
So this is your Hoffman test. You just click here. Now, your null hypothesis is, now, in case of panel data, what I told you, your null hypothesis is random effect model is good, right? Random effect model is good. That is your null hypothesis.
Yes, sir.
When
It's
you are
better than
comparing,
fixed model.
yes, when you are comparing fixed effect model versus a random effect model. So here, what we are observing, we have to observe the value of the chi-square statistics, the value of the chi-square statistics, and the value of the chi-square statistics is significant, not significant, because it is greater than 0.05. Therefore, we can conclude that in our case, random null hypothesis is accepted, and we can say that random effect model is comparatively better than the fixed effect model. But when you are deciding that random effect model is comparatively better, then the fixed effect result will be shown underneath, right? This is your fixed effect result. When you are running the Hoffman test from the window of your random effect model, that is from view option, first you got the result of random effect model, then you are choosing the view option, then you are doing the Hoffman test. But when you are doing the Hoffman test, the result of fixed effect model will be shown here. The result of fixed effect model will again be shown here, right? So ultimately we have taken the decision the random effect model is better. Therefore, again we have to run this random.
Sir,
Then
you mean to say,
yes,
sir, you mean to say that the model which is more better, it will be coming on the upper side, and the model which is inferior, it will be shown downward in the bottom?
no. Again, I'm saying, when you are comparing these two model, fixed effect model and random effect model, generally what we do, first we establish the random effect model, right? First we establish the random effect model, then from the view option we go for Hofmann test, right? So when you are doing the Hofmann test, by default the fixed effect model, that means to which model you are comparing? The random effect model you are comparing with fixed effect model. So the software will also give you the result of your comparing model. This is called the comparing model or the fixed effect model.
Oh,
right?
Sure. Okay. Sir, can it also be possible that we compare the fixed effect model with the random effect model?
No. There is no option. There is no option to do that. There is no option to do that. Just we are checking here. Just you go to estimate, then panel option. Then you told that first you will select the fixed option, right?
Right, sir. Right, sir.
Then okay, let's see what happens. If it happens, then good. Fixed effect model, but I have not examined it earlier. So this is your result of fixed effect model, right? This is the result of your fixed effect model. Now what you are telling, now you go to view option, right?
Yes, sir.
Then fixed and random effect testing, then you coming to Hofmann test. Strategy clear? Yes?
Sir, please re-estimate equation. It is showing.
Yes. So the software cannot give you the result. Clear?
Okay.
So first you have to establish the random effect model. Then you can compare whether random effect model is better or the fixed effect. That means the previous model, the fixed effect model is better.
Okay.
But if you do the fixed effect model, then it cannot show the result of the Hofmann test.
Okay.
Clear?
Okay.
So that's why it is giving you the caution. Please re-estimate equation.
Okay. So we can only compare random effect model
with fixed effect model. And when you are comparing, the result of fixed effect model will again be shown. Clear?
Okay.
Just I'm showing. This is the panel option. Now we are going to random option. Then we are just clicking on OK. So you are getting the random effect model. This is the random effect model. 1.70 Durbin Watson. This is the random effect model. Now you click on this option view. Then you are going for Hofmann test. From fixed and random effect testing, you are going for Hofmann test. Then what you are observing, this is the result of your fixed effect model. Clear? This is the result of your fixed effect model.
Correct, sir.
Right. So this is the procedure. Now we have to establish, as on the basis of the chi-square value and the corresponding probability value, as the probability value is not significant, therefore we can say that we accept the null hypothesis, and accordingly we can infer that our random effect model is comparatively better than the fixed effect model. Therefore, we have to estimate the random effect model again for diagnostic checking and for establishing the equation. Now you are taking random. Now, when you will take the value of the coefficients of the random effect model, then how we will establish the equation? The question is, this is the table, but this table, from this table, with the help of this table, you have to establish the regression equation. So how you will write the regression equation? So you will write in this way: POV, poverty, POV equal to, you can also write down POV equal to
61.44.
61.44 minus RNFW 0.52 or 0.53, you can say 0.53 minus LIT 0.31. So from this equation, what I can say that if the literacy rate increases, listen minutely, if the literacy rate increases, then poverty ratio will decrease.
Yes,
Clear?
sir. Yes, sir. Yes.
Yeah. So it is in favor of our domain knowledge, because when you are using the econometric, or when you are using the EViews, this type of software, your basic intention is you cannot violate any economic theory. You cannot violate any economic theory. So if it goes against the economic theory, then it is very difficult to establish your result, right? So always we have to look at the economic theory, what economic theory suggests, and whether our result is following the economic theory or economic postulates or assumptions. That has to be kept into our mind. Clear? Now, RNFW. If the rural non-farm workers, if it is decreases, then the poverty ratio, it will increase. Just you observe here, rural non-farm workers, if this increases, that means more workers are now employed in non-farm sector or non-agricultural sector, then obviously what will happen? The poverty ratio, it will decrease.
Correct.
Clear? Clear. So all these things you have to interpret in the domain of econometrics, because generally we use the econometric software or the EViews software for the econometrical analysis. The econometrical analysis purpose, this software is very useful. But for primary data analysis or for only the cross-sectional data, I cannot suggest this software. If you want to analyze your, if you want to analyze the cross-sectional data, only the cross-sectional data, then my suggestion is you follow the SPSS software. You follow the SPSS software, or you can also follow the R software, R Studio, you can also use. But when you are dealing with econometrical analysis, or basically you are dealing with macro variables, then you may use this software. This is a very, very important software. You can not only do the panel data analysis, you can do entire time series analysis. Entire time series analysis you can do using this econometric software, but EViews software. But when I have already told you, when you are using the Stata software, then the panel data analysis, for purpose of the panel data analysis, the Stata software is universally accepted. The Stata software is very, very excellent software for the analysis of your panel data. But using EViews, you can solve the problem of time series data as well as panel data, right? So if you know the EViews, you can compute your time series analysis. You can also compute your panel data analysis. But if you want to do any cross-sectional analysis using EViews, then you will not get any satisfied table, satisfied graph, satisfied descriptive statistics. You cannot get. Clear?
Okay. So for that we have to use Stata.
Yeah. So clear demarcation is there. first, that's why my suggestion is, suppose one is a beginner, one is a learner, research methodology in the domain of research methodology, he or she must understand the SPSS in a very better way, because SPSS software, this is the fundamentals. This is the fundamentals, very, very user-friendly software. And when you are doing your analysis using particularly primary data, then SPSS software is a unique software. Then after that, you learn views, then you learn data and all these things. Then after that, you can learn structural equations modeling. Another software is also there. AMOS software is also there, analysis of moment structure or structural equations modeling purpose. And recently we are using RStudio. This is a very sophisticated software and universally acceptable software. That's why whatever the research we are doing right now, we are using the RStudio. This is also very, very good software and user-friendly software, right? So I will show you another data set.
Sure.
Yes. So just I'm closing it.
Dr. Mohit, be ready for R square.
G, good evening. There'll be a good exposure. For sure. आपके साथ हैं सतबीर जी.
Yeah,
This is a time to learn. Yeah, why not? That'll be a great exposure. For sure, Professor
really
Debashish
good
Biswas, it'll be a pleasure. Yes.
No, frankly speaking, it is a very good platform, and I am also enjoying. I am also enjoying with you.
Yeah.
G, correct.
Yeah.
Dr. Debashish.
Yes.
Hello, doctor.
Yeah, please.
Yesterday I asked a question about a data set that I have on my own, and I'm having a problem with it. I tried working on it as you have advised. I should increase the sample size. Please, I tried but it couldn't work. So I have shared that data with Ma'am Shivangi. So I want to ask if you can download it and then open it and see, so that if there is a problem with it, then we know how to fix it, sir.
Okay.
It's also a panel data.
Yeah.
See, I think that can be done in a separate session. Let Dr. Debashish finish the talk.
Yeah.
As per his schedule, because Mode, your problem is a specific problem. So
yes.
I think you need to connect
No.
with Debashish.
That can be done later on, I think.
Yeah.
Because he has to look after the data and see it. Yeah. Maybe there could be some transformation required.
I will also share my my email ID. You can send me the data, then so that I can look into it, and after that I try to detect what is the problem in your data set, right?
Okay, sir. Okay. So
I will help you. Don't worry.
Because Mr. Mode, after Dr. Debashish solves your problem, then you have to give a party to him.
I hear.
100%.
Yes, sir. Yeah. Thank you very much.
So let me finish my session, and after that I will discuss. Yeah.
Yes, sir.
Yeah.
Okay, sir.
So just I have to complete my session. Just again I am showing the eViews software by taking another data set, and for your recapitulation purpose. Yes, I am just showing you from the beginning, but very quickly. Go to file, then go to import from file. Then I'm just taking the data of yesterday, that is the day 4. Then open, then next, 3 times next, then finish, then yes. So you just click here, auto hide. Yes. Now it is visible. So first I'm showing the day 4 data set. You just have look it. There are 6 companies, 6 types of companies, and year is 2000 to 2010. And we have considered 3 variables: price, repairs, and sales. Just I'm closing it for your recapitulation purpose. So I'm coming to the software. So all these folders have been created. Just go to quick option, then go to estimate equation, or yes, estimate equation. Then you are writing your dependent parameter, that is sales, then constant, then price, then repairs. Yes. Now we have not chosen any options. This is none. Just click here. So this is your pooled regression. This is your pooled regression. And yesterday we have also got the same result. The R-square value 0.11. We got the same result. So this is your pooled regression. Now what we are doing, we are just click on estimate, then select the panel options, then you click on fixed, then click on OK. So this is the result of your fixed effect model, and only one independent variable has become significant, but the other one, repairs, is not significant. Repairs is not significant under fixed effect model. So now we are comparing fixed effect model versus your pooled regression from this option, that is view. You go to fixed and random effect testings, and this is your restricted F test. Just click here. So what is there? The probability value of restricted F statistics, it is significant. Therefore, you can say that your fixed effect model is comparatively better than your normal OLS. Now we are just clicking on again estimate, then go to the panel option, then select the random option, then OK. Yes, the random effect model results have been shown here, but the result is not good. In all the model, the result is not good because our data is hypothetical. But for comparison purpose between fixed effect and random effect model, just click on view, then fixed and random effect testing, then coming to this option, that is Hausman test. Click here. Then when you are running this, then the model, the fixed effect model, have been shown here, that I have already told you. And you have to inspect the value of the chi-square. And as the value of the chi-square, the corresponding probability value is not significant. Therefore, we can say that we will accept our null hypothesis, and we can conclude that our random effect model is comparatively better than the fixed effect model. Then again, we have to estimate the random effect model for diagnostic checking. And for diagnostic checking purpose, we click on view, then we come to this portion, residual diagnostics. Then we are choosing this option, normality test. So what is here? The Jarkabara statistics is 8.98, but the probability is significant. Therefore, you can say that your residuals are not normally approximately distributed. Clear, Stabirji?
Yes, sir. Yes, sir.
Yes.
Where it is not normal.
Yes. So your residuals are not normally distributed. And next, again, you go to view option, then cross-section dependence test, Passer and CD test. Yes, Passer and CD test result is good. It is not significant, right? This is good, but your residuals are not normally distributed.
Okay,
and
sir.
another option, it is not possible for me to show you, but you can do in the same way, right? If you use the upper versions of EViews, then you can also do it. That is the heteroscedasticity sets, but it will not be shown because it is given this features requires EViews 9.5. Please contact your EViews administrator. So I cannot show this. So thank you very much for your patience, and I have also enjoyed these sessions, 5-day sessions with you, and it is also one kind of good experience to me. So thank you very much.
Thank you, Dr. Debashish Biswas. It was a pleasure.
Thank you, sir. Thank you, sir. Most welcome. You are most welcome. So any feedback from the participants I want to listen? Because
feedback is good, sir.
Yes, Stabirji, please.
No, feedback is good that we enjoyed the journey of 5 days. We didn't assume or we didn't anticipate that it will finish so fast. कहते हैं ना पता ही नहीं चला. We didn't realize that we are at the 5th day today. Am I correct, Mr. Mode? Are we thinking that it is the last day for us to learn? Hopefully.
Correct, Sadhbir ji, correct.
पता ही
नहीं चला. It was a fast session. Ji, but very informative.
Thank you, sir. Thank you.
Yeah.
Sir, it is a pleasure. Debashish, Professor Debashish.
Very, very fine. Very fine.
Mr. Umfle will also speak.
Sir, sorry to interrupt. I just want to have a screenshot of all my participants. So just a request to please switch on your camera so that I can take the screenshot.
Yeah. That's a fine idea.
Sure, Shivangi ji. Sure.
Prasanjit, sir.
I am removing my mask because I'm in office. So let me remove it first.
And my best regards to Professor C.R. Bishnoi. Namaskar, sir.
Namaskar, sir. I would like to. I would like to speak after a photo.
Sure. Parul ma'am, please switch on your camera. Arindam sir. Tanu ma'am, please switch on your camera. Anup sir.
मैडम फोटो भेजेंगी ना?
हाँ सर, लिंक्डइन पर Adarsh sir and Anup, please switch on your camera so that I can take the screenshot. Okay, I think let me. Arindam sir, please switch on your camera. No issues. I'm taking it.
Our strategy is changing today with this data learning.
Okay. Sanjeev sir, please on your camera. I'm just taking it out. You have off your camera. 2 minutes. Thank you so much, everyone. Thank you.
Thank you. Roy sir.
Thank you.
Glad to see Bishnoi sir.
So, Professor Biswas, I thank you on the behalf of our university, IIS deemed to be university.
Okay.
And I am professor and head there.
April মাসে যেটা পেমেন্ট করছি
Hello.
না মার্চ মাসে
Yes, sir.
Hello. So we have 4 participants from our university. Actually, problem was that it was mentioned that you will teach only EViews. So
Okay.
many students could not join. And when I attended your workshop, then I was surprised that you are teaching Stata. So
Okay,
that
sir.
is a very good experience.
Thank you.
Your teaching style I liked very much. You are
you, sir.
always ready to answer the questions, and your technique was very simple, so that
Thank you.
all the students, all the participants can understand. And I suggest that if you plan further such workshop on Stata, full
Yeah.
session on Stata for
Exactly.
7 days or 10 days, then we shall be very happy to join your program. And
Right.
if there is other program on econometrics or any other program, we shall be very happy to join you. Thank you very
sir.
much
Thank
for
you.
your very thoughtful and very very good experience seminar workshop. Thank you again.
Okay, sir.
Thank
Most
you.
welcome. You are most welcome.
Thank you, sir. You are thanks a lot. I am planning with Devashish sir in January to conduct the workshop on Stata, and hope he will give me time to conduct the workshop.
Shivangi ma'am, I couldn't hear your last words. Can you repeat again?
Sir, I'm saying that I'm planning the workshop with sir in January on Stata.
So
On
that
Stata,
will be very good. We shall be happy to join your program.
Yeah, I just need time from Devashish sir, his schedule if he is free. I'm ready to plan his workshop in January for Stata. I'm just had a talk with him yesterday only.
And also see the timing is also convenient for most of us. Okay, right?
Yeah, yes,
The
sir. Yes,
timing,
sir.
yeah, the timing. I mean to say the timing of the means in the entire day. Okay, so that possibility of joining it becomes easy.
Sure, sir. I will.
Can I? Am I making you clear? Because maybe if you shift from 5:30 to 6:30 or 7, maybe it gets convenient. I don't know. Whatever be the timing, convenient timing, you see about that. Okay.
Sure, sir. I will look over that.
Rohit sir, you can propose a time in the group, and later on, based on the feedback from other colleagues and their convenience point of view, it can be decided accordingly.
No. Let the pain be taken by Shivangi ma'am. Let her take that.
No, Shivangi ma'am is already taking feedback. For example, this workshop, based on my
No.
request.
Since she is organizing that, so it would be better that whatever, because she has access to all the participants. So maybe most of the participants who actually request for a particular timing, that would be, I think that should be accepted by all of us.
Okay.
Thank you, Devashish sir, for giving time on Educate Consulting and conducting such a wonderful workshop.
Most welcome, madam.
And
Professor Biswas, thank you so much for the session. It was very informative. We have learned a lot, and really down the line also we'll be joining, sir, for Stata or any other things, even
Okay.
Yeah, thank you so much.
Okay.
Like what Professor Bisnoy suggested, maybe elongated one, so that the basics gets explained in a more, say, he gets time to explain the basics also. Maybe that could be also a possibility.
Yeah, that is correct. That is correct. We should have more than 7 days seminar.
Even I'm of the same opinion. Yes, very, very right, Professor C.R. Bishnoi. Sir, along with basics and applied aspect of it. Yes.
Yes, that is good.
Thank you. That'll be good. Thank you.
So we can say,
now everyone is demanding out. Please give me your time in January for the workshop.
Yeah, madam, I will discuss later on, because from the December my university will be open. So as I am acting as the head of the Department of Business Administration, so I have some pending works. So let it at first settle all these things. So then we can finalize the date at the end of the month of December. Otherwise, it is not possible to say right now.
Okay, sir. I would be waiting for your reply.
Yeah.
Sir, this was only a trailer. So like
No,
Bisnoy sir has advised, Mr. Gautam has advised, we would like to learn it from the basics so that we are a learned person like Dr. Bisnoy, so that we can make use of this in our practical research and practical life.
Right.
Sir, it was very wonderful from the bottom of my heart. I am thankful to you for your humble style of teaching. Really,
Welcome,
and
Sir.
your smiling face and your humorous nature, it is contagious. May God bless you with this smiling face all the time, sir.
Thank you very much.
We wish you and your family a safe and healthy life, sir. Thank you.
Thank you.
Bisnoy sir, you are a very senior person among us. I also pray to God that you remain healthy and happy, sir.
Thank you.
Thank you, sir.
सतवीर सिंह, आप बहुत अच्छे हैं, क्योंकि आप नहीं होते तो हमारा सेमिनार पता नहीं कैसा बोरिंग होता.
नहीं सर,
Exactly.
थोड़ा बोलने का
ये बिल्कुल ठीक बात है.
Gautam sir, your inputs were also valuable. Thank you, sir. You are also a learned personality in our this platform, sir. Thank you very much for being associated with you, sir.
Exactly.
Yes,
And Bisnoy sir, you are from which place, sir?
I am from Jaipur.
Okay.
I worked in the University of Rajasthan for 37 years. Then I was head there. And now I am working in the IIS deemed to be University, Jaipur. I am head of the department there.
Okay, thank you, sir. Thank you.
I am teaching econometrics. I also teach SPSS also.
Okay, sir.
So we in the university have econometrics by e-views. That is in the syllabus.
Okay.
And we are using the same book, Bhaumik. We are using the same book, Bhaumik.
Okay, Shankar Kumar Bhaumik.
Shankar Kumar Bhaumik. We have that book.
Yeah. Okay. Thank you.
Bisnoy sir, you are an inspiration, I think, for all of us, that at this age also you are still learning along with us. It is our, in fact, privilege to get taught by sir. It is a very wonderful thing that we are witnessing today.
Thank you.
Thank you, sir.
Thank you.
Okay, then Shivangi ma'am, we may close this session or not?
Yes, sir. Thank you so much for your valuable feedback and information for the workshop. And hope all the participants have enjoyed the 5 days workshop. And I would be sharing the feedback with all, and certificates will also be shared with you.
And I will also send you the PowerPoint presentations and the Excel file today, right?
Sure, I will be sending them then.
Yeah.
Okay,
Thank you to all of you.
Thank you so much.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Good night.
Thank you.
Thank you.
Good night.
Thank you.
Thank you. Good night.
Good night, sir. Good night.
Good night, Morgan.
Good night.
Yeah, bye-bye.
Good night. Bye-bye.
All sir, thank you very much.
Good night. Good luck, Sabir ji. Stay blessed.
All the best.
Good luck all.